What's going on, guys? My name is Matt, and while this may look like an old beat up GameCube, on the inside is actually an AMD APU gaming PC. Along with this, there are a number of cool features like having the original power button turn on the PC and functional front controller ports. This video is made possible by today's sponsor, Squarespace. From websites and online stores to marketing tools and analytics, Squarespace is the all-in-one platform to build a beautiful online presence and run your business. So like I said before, I built a PC inside of this GameCube, and while it was a lot of work, I'm really happy about the end result. This can not only play PC games like CSGO and Fortnite well, but it's also great for emulating a ton of console games. In this video, I'm going to tell you about all the features of this system, talk about the process I went through to mod this, and I'm going to be showing you the system's performance in a number of different games. Going into this, I had a few different goals and tentative plans, but until you actually have everything in hand and start modding, there's no way to know for sure how everything's gonna fit together. I wanted to do a GameCube PC because I haven't seen that many instances of people doing this, so I thought it would be pretty unique. The first order of business was getting a GameCube to act as the shell of this PC. I went on to eBay and purchased a broken GameCube in the classic silver color. It wasn't in perfect condition, but that was fine because to me, this just adds to the kind of old school / sleeper aesthetic. Once in hand, I needed to tear this GameCube down to find out how it's constructed and be able to measure for parts. I had my tools in hand and was ready to start, but then I came to the realization that none of my dozens of security bits would open the system. Lo and behold, Nintendo being Nintendo, they made their own security bit that was only ever used on their products. This is referred to as the game bit. One $5 Amazon order and a few days of waiting later, and I finally had the necessary tools to crack into the GameCube. Sure enough, the game bit opened the system right up, and after the first 4 outer screws, everything else in the system just used standard Phillips head screws. Pulling the top outer shell off, I was greeted by what I would consider a very dense and well thought out design. I next pulled off the front portion and easily disconnected the ribbon cable, then slid out the back panel as well. Next, I had to remove about 12 screws to continue disassembly, 2 of which allowed me to remove the power button and side fan assembly. This side 50mm fan was the only fan in the entire system, and from what I remember, this little guy was able to keep the GameCube pretty quiet. Next came off the disk drive, and beneath that was the system mainboard. After a few more screws, this came off and allowed me to take a closer look. Removing the heatsink revealed 1, a ridiculous amount of thermal paste, definitely gives me flashbacks to a certain PC build video, and 2, after a bit of cleaning, I was able to look at the system's CPU and GPU. The GameCube actually had an IBM processor and an ATI GPU. Well, by today's standards, these are very weak. Back in the day, the GameCube was competitive in terms of graphics quality. Finally, I removed the power unit and a few more metal pieces. With that out, I was left with a blank shell to work in. Now, I knew an ATX motherboard or micro ATX motherboard were going to be out of the question for this system, but surprisingly enough, even a standard ITX board is too big to fit into this guy. Because of this, I needed to get the smallest form factor motherboard available, which is actually called Mini STX. These are so small they don't even have a 16x PCIe slot and only support laptop style SODIMM RAM. Because I want this to be an AMD APU system, I needed an AM4 STX motherboard. ASRock does make one, but the only way to get it is to purchase an ASRock Desk Mini, which I'll talk about more later. But getting the Desk Mini not only got me the motherboard, but it also got me a power supply and a number of other accessories. Opening it up and taking the motherboard out, you can see that even this super tiny STX board will just barely fit. Even though the GameCube looks pretty tall, in reality the bottom 20 or 25% of it isn't open because of these indents for other types of cables and expansion. I knew I wanted as much room as possible, so I decided to hollow this section out and basically make it an open bottom box. The problem was there was a ton of plastic to remove. I decided to start by trying the cutting tip that came with my soldering iron. I realized how careful I needed to be with this after messing up part of the exterior of the case on literally the first cut. Luckily, that was a good lesson because there really weren't too many major mistakes after that. So I began cutting some more and found that this worked decently well. It gave me good control over the cut and allowed me to get into tight spaces, but it definitely left some ugly burnt plastic edges. After this, I whipped out the ye old Dremel to do some of the longer, more open cuts. Using a combination of both, I was eventually left with this. This is definitely ugly, but it gave me a nice hollowed out shell. This added a few inches of available height within the enclosure, which in a small form factor build is a godsend. I then cleaned the inside up a little with the Dremel and a low grit sanding wheel. Because the bottom had so many holes in it from the original removed covers, I needed to make a bottom mounted tray that would close off the system and be a backplate for the motherboard to mount to. So I cut out a piece of picture frame backing that seemed like it would be a good fit. I then used that as a template to mark out 2 pieces of thin sheet aluminum I had on hand from another project. I made most of the first cut with some aviation shears and bent the piece back and forth until it snapped off. I shaved a little bit off of the other side, then test fitted in the bottom cover. I realized that while a single piece of aluminum would be too thin and flimsy, 2 of them would work fine together. So I cleaned them off, spread some JB Weld on one piece, sandwiched them together, then applied a comical number of spring clamps and left it to cure overnight. Once done, I did a little extra trimming to make sure I had the perfect fit. To mount this to the bottom panel, I drilled a few holes in the plastic and in the metal. I originally intended to use rivets, but quickly found out that this wouldn't work, so I ended up just screwing the 2 pieces together and using a bolt cutter to cut the excess sticking out. Once done, I set in the STX motherboard and marked for motherboard standoffs, then came screwing 4 holes and installing 4 standoffs for the motherboard to mount to. Once the motherboard was mounted, I installed the CPU cooler, and RAM so I could visually see what room I had for adding other features to this system. I knew I wanted to add another fan and use the original fan mount, but to do this, it needed some heavy modifications. I was hoping to just pop out the old fan and add a new one, but after removing the old one, I found it had a non-standard mounting design that wasn't going to work. I first wanted to remove any unnecessary plastic that might get in the way of the other components. I did this with a Dremel while also removing the original mounting pegs. With this done, the new fan could fit into place, and I just attached it with a few zip ties, which worked pretty well. Part of the reason I'm using the original fan bracket is because it also houses the original power switch. This I wanted to reuse as the PC's power switch. I just unscrewed this from the bracket, then soldered on 2 jumper cables that will plug directly into the motherboard. I also desoldered and removed the original power input because it would have gotten in the way. I then drilled a hole for the cables to pass through, put the power button PCB into place, and screwed it down. Next, I lined up the fan where it would stay, making sure the power button was easily able to be pushed in and out. I then applied some glue, set the whole fan assembly into place, and clamped it down. Next came the most difficult and ambitious part of the project, which was trying to make the original front controller ports functional with the PC. The plan was to buy one of these generic USB GameCube controller adapters and somehow rig it to work with the original ports. Opening up the adapter, I found it consisted of 2 PCBs, one to accept the inputs from the controllers and another that interpreted those inputs and transmitted them through USB. The port spacing wasn't the same, so I couldn't just switch the old port PCB with the new one. The thing I figured would work the best was to make the contacts from the original ports extend to the new board. To do this, I first need to remove the ports from the adapter and desolder all the connections. I then soldered wires to act as extensions from each of the original contacts. I'm a soldering noob and found using these jumper wires I had on hand was the easiest way for me to do this. I just added some solder to each end and soldered them into place. Once all this was done, I could take the other board and solder each wire to the corresponding contact on that board. Once again, this is basically making an extension from the original ports to the new ones. The controller board that was part of the adapter had all of the USB contacts, and looking at them you can see only 2 data cables, which means one of the 2 USB ports is only used for power. Now obviously fitting this cable in the case and routing it to the back USB ports wouldn't make any sense, so I had to find a way to connect it internally. Luckily the motherboard I'm using has an unpopulated USB 2 header, so I first desoldered the original USB cables, then I cut one end of each of these jumper cables. I added a little bit of solder to each cable and connected each one to the corresponding solder point on the board. I made sure to use the same colors as original so I could easily tell what each wire was doing. With this done, the controller adapter is now able to plug directly into the motherboard through the USB header. So just to recap, the original connectors extend to the adapter board that used to hold the controller ports. That connects to the controller board, which then connects to USB on the motherboard. I'm pretty happy with this solution, and the only thing I was worried about was managing all of these cables. The next thing I wanted to do, which didn't end up happening, was make a functional top-loading disk drive. I bought one of these slim laptop optical drives but wasn't able to use it. The first problem was the fact the original opening wasn't big enough for a standard disk. Secondly, while it may have been possible to fit, installing it high enough would have interfered with stuff like the power button, the eject button, and the hinge mechanism. Because of all this, I decided to scratch that part. With a lot more time, effort, and technical know-how, this probably is possible, but for now, my little GameCube PC will have to go without one. For the back panel, the I/O shield that came with the motherboard pressure fit surprisingly well. To fill the gap between the I/O shield and the top, I cut out a small piece of sheet aluminum. This was glued into place, and when everything is said and done, I think the back panel looks pretty decent. Doing a quick test out of the shell, I found the system and all of the mods to be completely functional, which was great to see. Now all that was left to do was assemble this guy and start playing some games. Assembly went pretty smoothly. I condensed the front port cables as best I could, plugged everything from the top panel in. This included the USB connectors, the fan connector, and the power button. Then I carefully put the two halves together. All in all, it doesn't look perfect from the outside, but at a quick glance, no one would guess this GameCube was housing a PC. So now that you've heard about the mod, let's go ahead and talk about the parts in the system. Like I said before, this is an APU build. An APU is basically a CPU and GPU in one. What I went with is the AMD Ryzen 3 3200G. There's a Ryzen 5 APU, but I had this one on hand and it still works great for what I was wanting to do with this PC. It has 4 cores with 4 threads and has integrated Vega 8 graphics. This is perfect for stuff like CSGO, Fortnite, and Overwatch, and is perfect for most emulators. This slots into the ASRock A320 STX motherboard. This board is almost comically small and it has all the features I need for this build. This came as part of the ASRock Desk Mini A300W. This is a bare bones computer that I was able to use all the parts from except for the case. The A300W is perfect for someone wanting to build a really small APU build. For $150, you're getting a case, motherboard, cooler, M.2 Wi-Fi card, and a power supply. All you need to add is a CPU, RAM, and some storage. I can highly recommend the A300W, and I'll have it linked below if you're interested. For RAM, I went with a 16GB kit of SODIMM DDR4 at 3200 MHz. This really wasn't that expensive at around $75, and it worked perfectly at its rated speeds. It installs just like regular DDR4, but the DIMM slots are much smaller. For storage, this board supports 2 SATA drives, but I just went with a single 500GB NVMe SSD. This is an old OCZ drive, but I'll link a more modern drive I recommend in the description. The fan I used is a 50mm fractal design fan, which is actually surprisingly quiet. This acts as exhaust and indirectly pulls air through the other vent, which actually has a built-in dust filter. All in all, this isn't a crazy powerful system, but you really can't get anything much more powerful in this small of a package. Finally, a quick note on the power supply. This is a 150 watt brick that came with the Desk Mini, and it works great for powering the system. So now that you've seen the mods and learned about the parts, let's talk about PC game performance and emulation. But before that, I want to take a minute to talk about today's sponsor, Squarespace. I've been a user of Squarespace long before they were a channel sponsor. A while back, I had a business making and selling custom 3D printed phone cases. I used Squarespace because they did and still do have, in my opinion, the best e-commerce system available. Squarespace is an all-in-one platform that handles all the confusing aspects of creating a website beyond just design, with stuff like SEO tools and a really robust set of analytics. If you're doing business online, you need a website, and Squarespace offers the best solutions available. I recently made a new website for myself that links all my different online presences into one location. If you want to build a beautiful website and support the channel, then head over to squarespace.com for a free trial, and when you're ready to launch, go to squarespace.com/techbymatt to save 10% off your first purchase of a website or domain. Thanks again to Squarespace for sponsoring this video, and now let's get back into your regularly scheduled content. So let's now talk about gaming performance. In terms of emulation, I didn't try a ton of stuff, but I didn't know exactly what to test. So if you want to see more games emulated with this system, let me know your recommendations in the comment section below. For GameCube, I tested the Legend of Zelda Twilight Princess. This seemed to run perfectly fine, and I played it with a GameCube controller plugged into the front, which was a pretty cool experience. I also tested Super Smash Bros. Melee. This again ran great, which is to be expected because you don't need that much horsepower to run GameCube games. For Wii, I tested Super Smash Bros. Brawl, which is always fun to play. It seems to run fine, and I played it a lot longer than I needed to because you can never play too much Smash. The last game I tried to emulate was Breath of the Wild, which is a Wii U game, and which is notoriously hard to run. The game didn't crash or anything, but it was not a smooth experience with frequent lag spikes. I did take some time to try and optimize the settings, and with more tuning I may be able to fix this, but for now this is how it's running. Again, let me know what games I should emulate in the comment section below. Now let's move on to PC game benchmarks. Moving on to Fortnite, at 1080p competitive settings, the system averaged around 60 FPS, which honestly was a pretty smooth and enjoyable experience. Next, I tested CSGO at 1080p competitive settings. The system produced FPS that averaged in the low 100s. This was a pretty good experience, and overall gameplay seemed pretty smooth. The third game tested was Far Cry 5 to show you this APU's performance in a AAA game, and from the 25 FPS average it received at 1080p low, you can see that the system isn't really meant for AAA gaming. Overall, for esports games and games on consoles like the Wii and GameCube, this PC works great. I'm pretty happy with how this system turned out and hope you guys liked it too. Let me know what you liked about this mod, and also let me know recommendations for games to emulate and recommendations for other features I could add to this system. So yeah guys, I think this wraps this video up. If you did find this video entertaining, then give it a thumbs up, and also consider subscribing for more PC and tech related content in the future. And as always, this is Matt from Tech by Matt, signing out.